topic design thinking approach for MEMS oscillators. So in this topic you are going to give the every stage of design thinking, like define, ideate and empathize, prototype and testing. So all these stages should give the outcome for the MEMS oscillator design, which should be compatible with CMOS devices and also power efficient for IoT and wearable devices. So discuss one by one.
So the first step in design thinking comes this empathy part. So this empathy part deals and tells us about understanding people who uses this MEMS oscillators. So coming to the people who uses the MEMS oscillator in the field like IoT devices, airplanes and in defense systems, and also they are used in mobile phones also. So in this, what struggle they face? They face more struggles. First comes is they want an oscillator which are very small, so that they can be lightweight and they can be easy to be carried. And next comes is they need a reliability, high reliability. That is, even in tough condition, they can withstand with heat or shock. And the devices like sensors and mobile phones often runs in batteries. So this low power use is also very important in this. So they can be preferably used in stable frequency. So in case of stable frequency, it can be in the character of stable frequency as it uses even in temperature change also. It should maintain a constant frequencies. So this is what is struggles.
Come to the design part. How can we design a MEMS oscillator that are very small in size, strong, and it can be used as a stable, and it will be low power and stable. That will make the thing which is used for the future electronics to make the quartz oscillator to solve the problems.
Part of the design thinking experiment. So coming to the ideate part of the MEMS oscillator. First we're going to explore about the resonant oscillator, like a tuning fork, beam or disc shaped MEMS oscillator has been used. So the next is the packing. Derivatively packed is used to improve the stability of the package. So the next is the temperature compensation. We have used on-chip circuit, which is used for the automatic compensation. So the next is the low power design, which we have used the CMOS for its compactability on circuits to minimize the power consumption. So the next is the AI and ML for the self-control, where the self-calibration is used for the frequency drift and so on.
So let me give the prototype phase in this design thinking. So we are focusing on the building and simulating the fabrication before the actual fabrication, and we are simulating by using some tools like console multi-physics to analyze the mechanical oscillator and cadence or synapses for the circuit code design, and then spices for the simulating the oscillator loop behaviors. When it comes to the prototype itself, there is a few important steps in this. So the first step is we simulating the MEMS resonance for directly on the silicon wafer. So the second step is integrate the oscillator driver using the mechanical, and then the third step is we are packaging the whole steps and then testing it truly to make sure it's robust, handle to different environmental conditions. So this is the prototype phase.
So what does they have testing part, and there are all basic parameters around that. First is the frequency vibration and the phase shifting and the temperature reduction and the power consumption. And the real world testing is nothing but to detect the vibration among the batteries, and we have measured the batteries to detect the power consumption low, and it is used for low frequency to the environmental reduction and the basic methods of frequency shifting and phase shifting.
Design thinking approach for the MEMS oscillator. So in this we are giving a solution for oscillators like, so MEMS oscillator gives the very efficient power design because of it is scalable and programmable for IoT devices and wearable devices, and also it is compact and CMOS compatible,
because we have to interface the MEMS devices with the VLSI technology. So it is easily scalable with the CMOS devices, and also we are going to prototype with the cadence and synapses tools to arrive the better solution for MEMS oscillator, and also it gives very robust design. Okay, so we can it can withstand the vibration and shock in any cases, and also it can withstand the temperature variations in the electronic circuit. So these are the outcomes we are giving for the MEMS oscillator design. So thank you for your ideas.
Thank you.